For our first speaker of the day, day 3, we have someone here whose name I have to pronounce Swayo. It seems like some people in Holland and in Belgium call him Swa, but that's another interpretation. But Stefan is not really the German Catholic priest that you would be Googling now. No. But he has as well a very special interest in networking, security and measurement. Skill set is fellow name holder that you can find Googling on Wikipedia, presumably is using as well. Swayo is a well-known player in the internet field here since more than 2 decades. And being involved in various programs, events and committees like, if I pronounce this right, Euro 9 or Euro IX, yeah, and DNOC. So some of you probably know him. He's as well a founding member and managing director of E6 for 15 years. So that makes him, besides being an old fart like me, he's above all a time traveler, an everlasting wanderer, an explorer, a learner, and heavenly willing to share his experience and knowledge with all of us. So I have the pleasure to introduce to you Swayo. Please enjoy.
Perfect. So good morning, everyone. There are a lot of people here. I have not expected you all here. As I was reaching the venue place in the morning, it was empty. There were no one in the tram and no one on the streets, and it's good to see that some made it today. Even it's day 3, and I know that's really hard for you. I really thank you very much that you joined me for this talk. So, as said before, and as it was announced, it's a little bit about net neutrality. This is the red line through the whole presentation. It's a big buzzword. I'm not really a legal guy. I'm not in economics. I'm coming from the network side. And don't be disappointed. I will not tell you anything about big legal things. I think there was a talk yesterday by a lawyer, which was much better than I could do it. And so don't be surprised if it's all a bit network-centric. So, as I work for a company, standard disclaimer, if you like, read it later. So, what's this talk about? I will show the commercial aspects and how they influence the internet, and especially the internet access. And this is the only part of the internet where we actually get numbers, because everything else is some way in the hidden, in the cloud, in the dust, in the fog, name it. And then I want to give you some glimpse what arguments are used by advocates and opponents of net neutrality. That will be the last slides. And this all was inspired by a movie made a few years ago. And I have their presentation during midnight. All Creatures Welcome. So maybe some of you have already seen this. I have a small part. Actually, it was a 3-hour recording session. It was 8 minutes left at the end. I'm not as lucky. We had 120 slides. We are now down to 80, so I have to hurry a little bit. So let's start. These are the topics I want to discuss today, I want to present today. Early days, where it all started. And funny enough, the first paper you can read, which has a little bit relation to the internet, is Intergalactic Computer Network. Intergalactic, 1963. And we have then the ARPANET. Most of you maybe already heard of it. This is the predecessor of the internet as we know it today, operating for a really long time, 27 years. And it was sometimes misinterpreted as DARPANET because of the naming. The company, actually the entity behind it was the ARPA. ARPA was later also called DARPA, therefore it's DARPANET. It's the same network, no difference. Milnet was split off later from ARPANET. And I think the most important part of the sketch is the NSFNet and then later the NSNet. There will be some slides explaining why they are important. So that was a good time, by the way. On one page, the whole internet. You cannot do it today anymore. I think we would need all walls here in this room to have only a tiny glimpse how the network looks today. But this fits on a piece of paper. And actually, if you look at it, this is a quite nice mixture of universities, say Stanford, I can see there UCLA, USC, Rutgers. The right blue file, there's ARPA, there's the RAND Corporation, which is a commercial one, but there's all companies like DEC and Xerox. And as you see, in the beginning, there were already people not only from the research community using this network, there were also commercial companies involved in it, even if they were on the applier for the hardware there. So, as I had said before, NSFNet, I think this is one of the important networks they built. National Science Foundation has built 5 new supercomputer centers in North America. They wanted to connect them. Our problem was then, is researcher at this time has for every computer, every supercomputer was built, he has a new terminal on the desk. And think of it, 5 supercomputer center, 3 others, you have 8 screens, and every screen has a different command set. That's really boring. And as these people try to do, don't want to do more work than they actually have to do, they're really trying to make it easier for them. So they said, okay, it would be nice to have one terminal, and that connects to every these big computer centers. So NSFNet was founded. NSFNet actually exists from 81 to 95. 85, sorry, to 95. Bandwidth is funny. It starts with, we would call it ISDN, Integrated Server Digital Network, 64 kbit, 56 kbit. This is the American speed, and went up to 45 megbit. And later there were also 600 megbit, but this was in the last years only. They invented something called a tier. Anybody heard of the name tier and the relation to network? Thank you, 1. And maybe some guys from the research community in the front. So what is a tier? This is a definition for this, a level or grade within the hierarchy of an organizational system. Actually, it only says they're the big ones. They connect, they have the eagle view, they connect every location. Then you have the more distribution layer where you have 2, which maybe you could think of big cities or regions where you have an operator covering this area. And the third, the green tiny circles, that could be your access provider. Maybe some of you have already heard from something like in Berlin or Snarfur or, but NetMBX, but this is all Berlin internet providers, smaller ones. They would actually be layer 3. So the goal was actually, with NSFNet, the goal was research and education. But they phrase it primarily. That does not say that they're not allowed to do commercial things there. And they set up an acceptable use policy. Actually, one of the first policy ever invented for a network, and that not states that this acceptable use policy is only for research. They said, it's not important who you are. Accept our rules and you can use the network. Nice idea. Everything non-commercial could work on it, and the NSF, National Science Foundation, actually does not monitor it, so you could do actually anything you want to do on it. And that was the reason why they got problems with the regional ISPs in these times. I wouldn't call them ISPs in these times, call them regional networks. And problem was that actually, what was the killer application in these times? Anybody knows? World Wide Web was later. Usenet, net news, mail, all these old, really great stuff. Some have already heard of UCP and dial-in, and even in, well, I think they dropped it a few years ago, this dial-in stuff in Linux distributions and other operating systems. They canceled it because nobody uses it anymore, but it was the basis. The killer application was email. They have 5, 6, a dozen different email systems in America, and with this NSFNet, they could connect these mail systems. So you could send email, if you were at CompuServe, to TimeNet, to the research community, without having 5 different emails accounts and to use your modem to dial into 5 different platforms. You could use one and it was forwarded. So, as I said, interconnecting mail servers, actually, they were more commercial. To give you some names, Alternet, later called UNet, PSINet, SurfNet. And you see now comes economics in the early stage. So economics covers both commercial and non-commercial aspects of the internet. And it's really hard to find a really good definition. I think I've found one which explains itself. I will read it for you. Internet economics describe various facets and how we build, operate, and use the internet, and look at these activities from a perspective of economics. Nothing more to say about it. ANS. So what is ANS? And this is also one of the last slides for the first part of the presentation. ANSNet was actually founded by Merit IBM MCI in 1991. If you look at the date, it's actually with NSFNet operating to the late 90s. It's actually had two hearts in his beating in his breast. There was non-commercial and commercial. The non-commercial part was the NSFNet backbone. This is more the tier one. You have seen these red clouds there in the tier presentation. That was NSFNet backbone. Then you have the more commercial aspect called core, commercial plus research. That was the actual backbone where it runs on. So they shared the same media, research and commercial companies. They used the same backbone there. And was later sold and was switched off 2015. Actually, 3 years ago. Actually, this is really not happened decades ago, only 3 years. So these things live a long time on the internet. So, start of conversation of the internet, definitely with ANS, definitely with ANS core. And then somebody said Usenet, NetNews, the first mailing list pops up and asks, hey, actually, who pays for the internet? And that will be my next topic. Who will pay for the internet? Because you will not get everything for free. And even the research community, even as they have deep pockets, as an example, ARPANET was founded with $1 million, which they took from a missile defense system. So that was actually the basis of the ARPANET and base internet we use was money they actually used for a defense system for missile rockets. I think this is quite impressive that it was possible. And 1 million euros in this time, it was $1 million, was really a lot of money. So, network access points. Network access points, as you see in the hierarchy, you have to hand over traffic to the next level of your hierarchy. It just goes up, and these points where you have the all connecting, where they all connect, they're called network access points. And that was a problem with the first network. Actually, you have to use the NAPs, and you have to pay for the NAPs. So, how it looks like. We have used the tier one presentation a few slides before. And as you can see, the red clouds, think of it as the NSF backbone or the NS core. And they changed a little bit of money because they were all over North America. And it was not for free. But interesting is the second part. And now look at the blue boxes. In the blue boxes, they have to pay money to the NAP points, to the network access points. And all the traffic they transfer from 2 to 2, and say the left is West Coast, the right is East Coast. It's actually, you pay twice for your traffic because both parties paid for the traffic to the NAP. In a way, it makes sense because it was a good service who could afford a link between the West and the East Coast in these times. It was pretty expensive if you wanted to have a really good bandwidth there. So, but what's the other case? If you are both in the same data center, and maybe the other node, the other blue node, is standing in the reach of your hand, why should I transfer all the traffic to a NAP, pay for it, and send it back down? Paying for traffic which I actually could transfer if I put a cable between these two sides. And that was the starting point of the internet exchanges. And the internet exchanges were something who aggregates this approach to put these connections inside the data center, put them together, this regional stuff, and to give them the opportunity to, we call it peering, to transfer traffic without paying for it. Both sides could transfer it. That's the ideal approach. So, that was it for the NAPs. So there was Europe 2. Yeah, we have the DFN. Somebody knows these guys. They have started 1985 with the network based on OSI protocol. I will not talk about OSI, that would fill an hour. But it's definitely not compatible with the network we use today and called the internet. And there were two other universities. The older people maybe know them. This is Unido and Xlink, based on universities. One is in Dortmund, the other one was in Karlsruhe, which actually have already connectivity to the ARPANET, to the internet in the US. And they used their packet-based transport mechanism. It was quite expensive, but that was actually the foundation, not the DFN. They switched over later. It took them some time to accept that they cannot have the research community put on OSI, even if it's maybe the better protocol. I don't want to discuss it. It's, yeah. So, individual networks, an association was founded in 1992. It was quite old. As I've seen this, I thought, oh my God, I have never thought that it's so old, that they started so early with it. And I have to say, good work, guys. That was really good that you were there. And a tiny side note in history, the English guys already had in 1973 connectivity to ARPANET, 12 years before the German scientific network started with OSI in Germany. So, well, okay, German Telecom. Everybody knows Bildschirmtext. I think we all have seen this logo, more or less, in the last 20 years, a lot of these congresses. And it was one of the first texts of the CCC. And how is it related to internet? There were 850,000 CDs sent out with a Mosaic browser when they used the BTX platform to dial into the internet. Even if it was low speed, that was one of the reasons. This was actually the starting point. Dial-in connectivity over the BTX platform. And there were also other companies like CompuServe and AOL, also dial-in pools at universities. I can remember the time where we have Technical University in Berlin. We have had 8 modem lines to the internet, and they were really crowded. And we have these, you know, with this around, you have to dial with your finger, and almost not pushing buttons. So you have really to dial something there, a rotating dialer. So then there were smaller. I already have said some names: NetMBX, NAFU, other companies. You have to think of them as these tiny green bottles in the tier models who have actually access to the internet and give you dial-in platform there. So other services, was there a competitor in the market? Yes, they were. Some people maybe remember the name, FidoNet, mailbox systems, they were quite popular. And after internet was established, they were all gone. So, nice summary for the first half. Day zero of the internet. When did it start? 83, TCP/IP protocol was switched on in the ARPANET, and the old protocol was switched off. That was the first time that a network 100% ran on TCP/IP. The first email was received in Karlsruhe in 84, the e-domains in 86, and in 89. The hypertext protocol was invented by a guy at CERN, and I personally think this was for the commercial internet and for the internet for the private for private customers. This is an important thing because that was the first time that this cryptic internet suddenly got a face, suddenly got an easy-to-use interface. And in '95, already said before, German Telecom sent out these CDs, and people started to use this stuff on their PCs, and they had the first experience of things. Even if it was really slow, and Mosaic was maybe not the best browser in the world, it was a browser, and you could see pictures, you could see links, and so on and so on. There's a whole story behind it. If I would unfold it, you will not have. We would have breakfast tomorrow morning. It's really, really a lot of stuff happening then in the meantime. Therefore, cut here. Maybe this is part of another presentation. Should be done by any other guy or me. We'll see. So, network explained. That is maybe for some of you a very boring part, as you already know it or maybe work in this area. But let's look at the traffic flow on the internet. And this is a very, very simple model there. And don't blame me for it if you think that it's not right. We can discuss later. So, starting in the middle, the core. And the core, we have now again the tier model we have seen before. And the tier model, also the links between the big providers there, which actually do not pay for them, for the traffic. As you can see, there are a good dozen companies today. This is the actual list from this year. Quite international, a lot of companies from the first world. You see no not too much South American or African companies there. Also not too many Asian, but this is actually the people who run the backbone between the continents. So if you think of the clouds maybe as the continents and the crosslinks in between, they will supply you with this. So, and then we have the tier 2. You pay for this, some money if you want to have traffic there and exchange traffic. And if you're in the green area in the tier 3, you pay a little bit more to get access to the internet. And what I do not show is if it would go to a little bit further down, then this is the access. That's you actually using the internet at the end. So, in an ideal world, traffic would be for free, as you can see, between the green bubbles there, if they would have a direct connection, who should pay for this? It could be quite cheap there, but it's not reality. Reality is, in worst case, that you have to turn traffic from tier 3 to tier 2 to tier 1, and then back again to tier 2 and tier 3. So you pay a lot of money. Both sides pay for this. And that was the idea in the beginning with the internet, the NSFnet, like the Americans thought it could work. The reality is more like this. We have this tier 2, which is really the backbone of the internet, I would say. And there you have links between all these providers at this level. And if you see some of them have $0 there, that could be an internet exchange as an example, or a direct cross-connect between two companies in the same building. And now it gets cheaper for the green guys, and actually also cheaper for the guys sitting behind the green bubbles. And it could even be better if they have a direct link. And as the interconnection prices get cheaper and the long-distance links getting cheaper, this is also happening today. Good. Now, access. This is a really complex sheet. It's actually 4 kinds of devices. By the way, this company, I use the icons for the CPE devices there. They have the best icon set. There are 100 other companies who can supply with these boxes. So what we have there, starting in the lower, is the 4G, maybe in the next year with 28 gigahertz, the 5G networks in the metropolitan areas, the not bound on wire stuff. And then you have the fiber to the home. That's, you get the fiber there, and some magic technology transports lights into your flat, and then there's internet on it, and some other stuff we will see later. Then the classical CATV networks, which are using coax cables. Now they have bandwidth reserves up to 2 gigabit per second, and now sell 500 megabit up to a gigabit. And then going up, the orange ones, is the copper lines. That's the 2 wires of copper going into a flat, once used for telephone. Now it's actually all internet protocol, or it's actually transporting internet over another protocol. But there you have the differentiation. We call if you look at the first gray bar on the left, and then the second is more to the right, this space in between you call the last mile. The last mile is actually from the access, where you get access to the internet, to the core, to your own flat where you're living, where you have your termination device, your customer premise equipment, CPE. So don't forget, this is not access. There's another infrastructure between core and the last mile. This is the access layer. You have to distribute, because these areas you have to cover are really big, so you have another layer of network stuff and equipment in between. It's called the access layer. All this stuff is connected by fibers, and later we will focus on the DSL links, most common, and I think they are the only real numbers we can compare. Coming to the content. Content delivery. In the middle, it's the core. You see the tiny world map inside, and then you have all these areas: North America, Africa, South America, sorry, Europe, China, and then you have Australia and Africa. Africa will be later inside. I've sorry, forgot it in this slide, but it's there. And there you have these big cloud providers. Everybody heard of AWS, Azure, Oracle, and even companies like Salesforce and SAP, who actually sell only one product, are now put into these corner of the cloud operators. And they have data centers with a lot of servers inside, which are located in your region. And there are also initiatives like in China, Yuan, I hope I have pronounced it right, and we have also cloud services in Germany, which are really focusing on the local market. So this market grew. There are more competitors on the market nowadays, and their market is changing fast. As you can see, the blue arrows I have there, that's actually internet protocol. That is something where the traffic you use is transported. If you take Google with Alphabet, if you have the Google search engine, it's actually running on these blue links. But nowadays they also connect these areas with their own private infrastructure. So traffic comes closer to you and you only see, and this is a bad thing for research, you cannot see where the traffic actually comes from. I'll give you an example. I think we have some time for this. Think of it the way you have a service on your smart device which has a JSON interface, an interface which only pulls data and presents it in a nice way on your device. And then you connect to Frankfurt to AWS. This is only an example. You can go to Azure. It's the same story. And then where's your data actually stored? Is this in Frankfurt? Is all the personal data stored in Frankfurt? You do not know, because the same data could be in North America, it could be in Asia, or it could be split in both locations. And all the data from this point where you actually pull the data to your nice interface, all these data, what happens behind, is transported over their infrastructure. Maybe based on IP and internet protocol, but it's not public internet. You cannot see what kind of traffic flows there. And therefore, they built actually a second network layer there, which is a quite interesting thing, but could be, think of the tier model. Which traffic is actually going away? Actually, the traffic from the tier ones. Because the tier ones normally transport traffic from continent to continent. But if this is actually done by the cloud providers on their own, with their own equipment, with their own links, there's no traffic on these links anymore. And to give you another idea, you have these transatlantic fiber links, undersea cables. More than 90% of the traffic is not internet. This is enterprise, this is commercial traffic. So the internet itself use is actually a tiny part of the traffic produced worldwide. There's a good reason why. So, content, classical one. We started with a server somewhere, have a really thick pipe there, and then we connect to the core, and then it's distributed worldwide, and then you get complaints from Asia that your server is too slow, and what you can actually do, you can put in every location a server. It's quite expensive, and then somebody had a really brilliant idea and said, build a content distribution network. There are some vendors, names are on the right side of the sketch, who built caches, these red tons I have there. They put all of these caches into the core networks as near as possible to the client to make it as fast as possible. These caches are normally transporting your content by copying this content to these sites, and by DNS redirection, name service redirection, you are getting the traffic from the site which is nearest, which means that you get it fast and you do not have to wait a lot. There's later a sketch that explains why this is important, why you have to transfer traffic really fast in this network, for economic reasons. So, then there's a special case, audio and video. First look, yeah, this looks like CDN. It's actually the same thing. If it's a text or it's a movie or an audio file, why should I make a difference there? Actually, there is a difference because you distribute this audio and video stuff because of digital rights management things and issues. They are different in different areas. There is different content. There are even services which you cannot get. One of the sad things, maybe as an example, in Europe, BBC has services online which you cannot access from Central Europe. And that's not the cause because they have Brexit. That was well before. So the problem here is that this content is most of the time local content. So now, maybe some of you heard of it, OTT. And I did not miss an O there. It's not called Otto, it's over the top. Over the top means these are operators who do not have their own network. They do not have some access network like Time Warner in the US, who owns a cable network and who owns film studios. So they have a line of producing content, storing it, transferring it to the end customers and get paid by the end customers for this content. Now, these people do not have this. They really rely on the stuff you have, that you have a running network to the customer which has enough bandwidth and enough quality of service that the experience for the end customers is a good one, a great one, because else you wouldn't pay for it. And this is only a definition for this. Who is actually doing this? Search engines, social media platforms, all of video on demand. This was the example before in the sketch. And yeah, and the last topic is, I think, this thing where all the discussions about the economics and who pays for the internet actually starts, especially in Germany. Carrier does not participate in the earnings. And the earnings here can be different kinds of earnings. The one is cash. If you have a connection to the internet, you pay cash money. These OTTs can also be paid in a different kind of money, your personal data. By advertisement as an example. You're accepting this, and this is the second, it is much stronger, and this advertising stuff, no access provider sees any money from this. This is actually really privately owned by the OTTs. And I think for the OTTs, they do not care about the cash you pay, most of them, they want your personal data. Has much more value than every Bitcoin in the world. So, we now have a nice model. We can make a shell with access, and the next shell is the access layer, and then we have the center with the core, and then inside these middle part we have cloud providers, CDNs, and other services. Actually the stuff that people in access wants to have. And is it really true? Yes, it is true. This is a sketch from Kaida. They have really nice. They have really nice pictures of the internet there. I can only, if you're interested, have a look at it. There's a link there, kaida.org, and this is a map from 2017. And you can really see how these onion shells develop there. You have the outer layer with the access, and then it goes inside, and it gets more dense and more dense and more dense. And then you see there's the core. There's actually really a core of a few sites which supply the internet with content. So, internet economics, mentioned it a few times before. Now we are diving into this topic. And in this topic, we have the access. Everybody has seen the street cabinets. In Germany, it's called KVZ. It's a really, really nice name for Kabelverteiler. And yeah, this is regulated by the Bundesnetzagentur. This is a German regulator, and they said, yeah, everybody should get access here. Therefore, we have these frames, has to be opened for other carriers too. And there are actually 2 points where you could use the copper cable. This is the Hauptverteiler. This is the master distribution frame. This is a building which is about 1,500 meters, 1.5 kilometers away from you, if you take the length of the cable. That was the classic one. This is the place where you got 10, 15 years ago your ISDN connectivity, your internet connection. This is also on these 1,500 meters, you can run ADSL with 16 Mbit. But nowadays, most of these people have 50 Mbit or 100 Mbit or even more. So how to do this? Because if you have more bandwidth, you have to get closer to the customer. So therefore, you have these KVZs, these street cabinets where you have active equipment inside. And the last discussion we had were bitstream access. And the bitstream access, this is the stuff where actually it got more important as the vectoring came, as 100 megabit links to the access has happened. The the copper bundles you have there, you can only be run by one operator. So you cannot get the physical cable anymore, you can only get the IP traffic on it, and you transport it in layer 2. Layer 2 is actually only a transport layer. You have to put layer 3 on it. Layer 3 is actually the IP, the internet layer. So you get a layer 2 connection there, and this is regulated, and there are prices for this. This is public stuff, you can read it. Bundesnetzagentur, you have to look a little bit, but you will find it. There are lists, and there's also, this is all public. You can read this stuff, how much money costed. If you go from master distribution frame, this is the thing which 1,500 meters away from you, you pay 10 euros per month. By the way, these prices are all without VAT, without Mehrwertsteuer. So don't be surprised that you have on your bill different numbers later. This is 19% less. I cannot compare with these prices are always in without VAT. So as you can see on the right side, this is from Buga. The price actually went really slowly down from the price. So it's actually so. And if you compare it with the price of the internet, if this is the connection to the link, the price of the link as described there, the internet price goes down this way. So actually, price for the connectivity for a copper line stays the same, and the internet goes 100 times cheaper, the traffic you transfer there, and in the same time frame. So, physical stuff, yeah, it's a lot of money inside these things. So from a street cabinet, which is 300 meters away, a little bit less, 100 meters, then it's only 6.77 €. It's a little bit less, but still enough. So, bitstream access, already mentioned. Important keywords here is vectoring. And second important keyword, layer 2 access. You have to go to a point of interconnect from the operator of these vectoring devices. And then you have to connect your equipment there. And then you get a handover there of the traffic of your customers. Yeah, and how does the carrier pay for it? There's nothing like a flat rate there. Actually, you pay a base price, and there's some little bit of traffic included. But if you want to have more quality of service traffic, then you have the problem that if you want to have more, then you have to pay more for this. As an example how this is described, there's later a sketch for this here. This is how it's described there. It includes a monthly included total traffic of 1.5 megabit in average, and a real-time share of 0. And then you have stream applications, so they split this traffic up. And as you can already see, they already look into the traffic in the bitstream access, and there is quality of service involved. And this is actually the price for the internet. If you take the prices from two vendors, it's German Telekom and O2. Only important here is the orange part. This is the price actually of the internet traffic you have on these links. And as you can see, this is nothing compared to the rest of the price. The blue one is the hidden price. This is all the stuff from access to backbone and everything which is there included. So, the provider sells you traffic for a gigabit of 60 euros. And if you look at the market, low quality is about 200, high quality is 2,500 euros for 1 gigabit of traffic. So it's actually 3 times more expensive to buy this on the free market, or up to 42. We call this an overbooking factor. This is one of the trade secrets. Nobody will tell you, because all the business cases of the carriers depend on it. So, Internet Traffic Core defined that there's a huge difference in price, as you have seen, in quality, and there are different important things. One of the important things here you have to think of, it has to be redundant and resilient. So normally you have 2 lines where you private have only 1 link. You have 2 links there to get the connectivity there safe. So content delivery. In former times, every service was transported on a different layer in a different way on the net. And then they put IP there. IP is not internet, it's a protocol IP, it's not the internet. And what they did, they used this to migrate all the stuff to IP to make it cheaper. But they still think it's a different thing here. And then the OTT came, and they have the same services, but they use the part of the internet you supply to your customers. So you have now two VOD services on your network. One is, in the eyes of the access provider, their own, and the other thing is the VOD service, which is run on the internet, and they need bandwidth for. And who pays for it? To give you an idea, Call of Duty, 100 gigabyte of download, that equals to 14 hours of 4K video. Each video has 7 gigabyte of traffic. So why do you care about it? Fast internet normally means that people who have a slow connectivity normally wait up to 30 seconds before they say 50% of CPUs, no, this content is not important to me, drop it. And if you have a fast connection, this time shortens to 5 seconds. So if you don't want to lose customers, you really have to have fast connectivity there. So this is already said during the talk. We can skip this one as I'm a little bit running out of time. I wanted to go to net neutrality as one of the last points. Net neutrality defined by the US in 2011. Net neutrality is the principle that internet service providers treat all data on the internet equally and not discriminate or charge differently by user, content, website, platform, application type of attached equipment or method of communication. A lot of topics covered there. This is the, I would say, this is based on the services of the old internet, not really taking into account that there are OTTs in the world. So what we have in Germany is a regulation, and the regulation covers a lot of things. One of these things is net neutrality. So topics discussed in the public is how neutral is the traffic? Is traffic equal? Scheindebatte, bill debate, deep packet inspection. You will see this in the press on a regular basis, that these things pop up there. And the last thing is two classes internet. This is one of the strongest arguments for people who say we need a regulation there. This is a list of pro and contra arguments. I think only to say is, the last line I think is in a way the importance. It's a good summary of all the topics before. The people who say we need net neutrality say nobody owns the internet by design. Remember, as I started the presentation, the internet was equal for everyone. It was shared by commercial and research. So by design, actually, there is no quality of service inside. That was not differentiated. And the contra people say, the people who say we do not need net neutrality, say they own the network. They can do what they want with it because they have paid for it. So it's their property. And then this can happen. This is a Portuguese provider. And this is really scary in a way because they have these SmartNet contracts where you get flat rates for bundles of services. What I really find scaring is this. If you look in the middle on the last line, there's even an email service included there, which was really surprising for me. Why is Google Mail there? I can think of video-on-demand services, yes, no problem, but why I have a mail service? And this is really a scary thing. If they start to put quality of service on the base services and not only on the video-on-demand service as an example, then, yeah, I would say I would be scared. So, Outlook, that was requested by the, and I think then I'm nearly at the end. This is an outlook. This is a mainstream text. You can read it in the paper. So what you can see here, there's growth rate between 15 to 58%, depending on the services. Video is one of the strongest with 58%. And there were numbers. I do not know where the source is, and I think we have to have really looked careful who has supplied you this number. Netflix doing 15% of the internet worldwide. That's a huge number. And that more than 50% of the internet traffic we have today is encrypted, which is a good thing, by the way. I like the idea that a lot of these traffic cannot be cannot look into the package with deep packet inspection, can say, okay, this is this traffic, or what kind of traffic is there transported. So, Alphabet, Google, 40% in the APAC region. We'll see this in Europe too. A little bit less, I think, because we have also strong competitors here. And what are the challenges? What can we do actually here? Net neutrality will be redefined. That means we have to take into account that there are these OTTs. They exist, but we have to find a way to how to handle it. I do not know the answer to this, and it has to be a discussion which will maybe go on for a few years. And The risk we have here is a walled garden. What is a walled garden? Walled garden is everybody has a mobile phone. And what you have there is that all the services you have, you in a way, is in a garden which has a huge wall around it. And this wall has gates. And everybody who wants to go through these gates to you as a customer has to pay the one who owns the gate. This is a walled garden. And the walled garden can be a good thing if you have a golden cage, then it's okay, maybe, you're lucky. But there are a lot of examples where this walled garden is a bad thing because it limits the access. And this walled gardens in the mobile world could now swap over to the access world. And if this happens, you have seen this Portuguese provider, where even a mail service suddenly gets something special, you have to pay $4.99 for it. This is called walled garden. Do you want to have this? I wouldn't like it. More encryption, more internet protocols will be transported in tunnels. Who wants to look for the keywords DNS over HTTPS and quick. More web browser-based applications is ongoing. More and more stuff. You do not have applications on your laptops. You normally do only a good browser to run these things. And as I've seen presented before, these links between these different cloud zones will grow. So actually, the internet traffic will only happen between you and the content. And everything behind it will be handled by the cloud operators. And more, question mark, paid QoS, quality of service, we'll see. So, and the end, a personal statement from my side. Current discussion about net neutrality is needed. We built the internet as a network for exchange of ideas and nearly free access to information worldwide. But this covers only the first world, this discussion. So we shall never forget that it's our responsibility to preserve the original idea of the internet. And close, refreshing memories. It was enjoyable to do this presentation, as I've also found some stuff I have known before. And I thank you all very much for your patience, and thank you that I could present it to you.
Thank you, Swail. Fantastic. I personally have quite some questions here, but I presume there are some in the audience. I see someone at number 2. Please shoot.
So, I actually have a very short one and a little bit more philosophical one. So the short one is about around slide 60. You showed some QoS numbers.
60.
Around 60. I'm not. I can't remember exactly. Where did you get those numbers from? I mean, 0.001 megabyte per sec for critical services or something like that. Are those real numbers, or where are they from? How did you come up with them?
I repeat your question. Where is my source of information for all these numbers I presented here with the traffic, and how do I come to such low numbers like €1 for this stuff? And the base of these numbers, it's hard to get this. I used, and I have a calculation here, but this talk was only 45 minutes, so I couldn't put it into the slide deck. It actually uses the access numbers and extract this. And then I mix it up with the stuff from the mainstream facts later, where you see 12% is Netflix and 58% is this traffic and 40% is Alphabet. So I put it in. It's a look, and I definitely have to say this, in a crystal ball. This is a wild guess. Even if I would know the numbers, these stuff is top secret. It's business secret. Even if I would know them, I couldn't tell you.
Okay. And one other one, actually, that you say that walled gardens would be great. I tend to agree. No?
No. You got it wrong. I said, maybe you're lucky and you have a golden cage. Your provider gives you a lot of things and you are happy, not from my view as a network operator, more from you for a customer. You see, you don't have to forget, you are maybe 2% of these people who use the internet. They are 98% outside. Think of your parents, think of your grandparents. These are the normal internet users. And therefore I said, these people could be happy with the walled garden because they feel like in a golden cage. If there's a good support, why should they change it? We would say it's limiting us. And but we are a minority here.
What my main question is that I sometimes feel that there should be huge technological changes down in the backbone. I mean, IP is that the real good thing forward? And there are some very interesting ideas like named data networks where you actually address the data that you want to reach instead of the endpoints.
Yeah.
How do you see these picking up in the next decades? Do you see any appearance of these in?
Yeah. So I hope everybody has got this question. I see what you mentioned in the beginning in the interconnection of the cloud providers. Because they are free, they can use their own proprietary standards. And what's really working will swap over. It's like with Quick, as Google invented it, and I'm not sure which version number they are now. But they started it internally, and then they rolled it out. And then there will be an RFC, and then there will be standardization. Standardization in the internet is not a DIN norm, it's actually a request for comment. And if everybody agrees, then everybody will be accepting it and implementing it. Sorry, if there's more questions, I will be here. I'm happy to discuss this with you, but I think there are some more people
yes,
at the mics.
There are some more people. And certainly if we discuss the golden cage there, think about the new developed world, and there the cages are maybe not that golden, but they need that environment.
I would like to have a sarcasm shield here, but was no time.
Number one, please.
I think one of the lessons of the Egyptian Spring is that you cannot shut down the internet if you want to suppress public upheaval if the industry is dependent on it. Mm-hmm. So do you see any moves of the internet industry to kind of create a public network that can be shut down while preserving business-to-business traffic?
I would say a very strong yes. I see that there are people pushing this and say we build a second, a third, a fourth, a fifth network in parallel to the existing internet. So remember the phrase two-class internet? Maybe extend it and say there will be an N-class internet. One for business, one for paying customers, one who pay for the extra quality of service, the third and the fourth and the fifth in any of this base internet connectivity where you can have not even see a Netflix movie because it's even with progressive download, it takes a long time for this. So it could happen, and I think this is one of the things we have to take care of, that this thing is not happening in the future.
It feels a little bit like taking first class in Deutsche Bahn from Frankfurt to Leipzig to me. Then suddenly,
do you think it's a good idea?
Different, yeah, you end up in a different situation. It's not like fast, but it seems fast.
Okay.
Mike 2, please.
Yeah. Hi. My question was regarding the the revenue streams for ISPs, and if it's considered that the infrastructure is acquired with public investment most of the time, especially for the big ones, which used to be part of the state and used to own the network in the first place.
Is it clear?
I think it's your point that I try to rephrase it a little bit, yeah, and maybe you can say yes or no if I get it right. You say that if you look at the access, we have these nice sketches with the links, coax, Kappan. All these infrastructure was built by companies owned by the government once, and now they're in private property, and now they sell back what we paid with our tax money. And I only copy the argumentation we have seen 5-6 years ago. And yes, I think it's problematic in a way, I can say that the part of the infrastructure itself and running the infrastructure, you have to look at it the way that if you want this infrastructure available for more than 80% of the time, you have to put money into it. This money has to be spent, and it was spent by the carriers in the last 10 years. So maybe you could say, or maybe it's hard to answer. I would say it's already paid off in the time before it was privatized, and the privatized people, the privatization and the rebuild of the infrastructure and extending the infrastructure was done by the private companies or partly public companies. And there's a good reason why they're allowed to sell this to us, because with the existing infrastructure 10 years ago, it would have been really hard. As you've seen, there were no street cabinets with active technology inside. This is a huge investment there. That wouldn't be possible. So you're right. 10 years ago, I would have totally agreed with you that it's unfair. Nowadays, I would say, there's so much money invested into the X by lots of these companies, so maybe there's a right to sell it to us, maybe. But the question here is, with or without regulation?
Good. Food for thought. Please, sir, shoot.
I have a question about these over-the-top services, and this is almost a political term, I think, which tries to say that this is a trick they are doing. And I think that I pay for my internet access, and therefore I should, after all I have paid for it, I should have access to it. And maybe it's only the way of the payment. If I pay for a flat rate, then maybe you have a problem with these over-the-top services, but maybe we should pay a fair price per gigabyte or terabyte of traffic as an end user. So why not increase the price of the internet access if I won't have free access to all these services?
Okay. A little more complex answer here. The first thing is, video streaming started with 2 Mbits per second. We are now at average Netflix stream 4 Mbits, and with 4K we are going up to 10 Mbit per second and more. Problem here is that the OTTs use the network in a way which is not intended to. The protocol itself is normally said that you have an average traffic, so that you guarantee an average kind of traffic. And what we do now is that we have these peak hours. So the over-the-top providers, if you come home at 6 or 5 and you switch on your video on demand box, you're not the only person doing it. So you have a lot of capacity to build up for this, and suddenly at 10 in the evening, everybody goes to bed, not maybe us, but a lot of other people, the traffic goes near to zero. So this peak traffic, the problem now is here, you can see the movies, the bandwidth is there, but it takes you a long time to get it started, or it takes in progressive download more than 20 seconds or more than a minute to start streaming. And as you see in the last sketch, if you have broadband access and people switch the stream of 50% of the people after 5 seconds. So what the over-the-top carriers want from the carriers is that they supply them with the bandwidth they need, that the customer is not switching off the stream in 5 seconds during 6 o'clock in the afternoon and 10 in the afternoon. And the internet was not built this way, sorry. This peaky traffic is really hard to accomplish. And therefore, the OTTs, it would be nice if everything would happen. You switch on every full hour, and maybe you switch on every half hour. The internet would be great. But both of you will switch on it at the same time, maybe at 8:15 after the Tagesschau. And
yes, but we both paid for the bandwidth. Yes, I was paying for this bandwidth, and now you say I cannot exit this because all the customers do it, but all the customers paid for it actually. Yeah.
You do not pay for the peak traffic. And this is something which would be actually the, in another presentation, sorry. The thing is, you're right. You have a guarantee with the bandwidth. It's a good point. Yes, you have this. But we are talking about peak traffic. And there's a difference between peak traffic and average bandwidth. I need a piece of paper and a pen, but we do not have here a call. And I think not the time. But I'm happy to talk to you later about it. And we'll be here.
It seems as well that in this universe and outside of this universe, there are some questions as well coming from the internet. Is there really an important one? Because we need to close here. You're available after this talk. But can I have the question from the internet? Please.
There's no question from the internet.
No
IRC is still deep sleeping.
Oh, that's good. They're sleeping then. You're awake. I take one more question, please. Yes.
Kind of connected to the last two questions, is there any role for public infrastructure? Like if local or the state governments took over the last mile stuff, does that actually solve the problem? Because of this QoS
no, will not solve. So give him a mic. Maybe here's the answer for this.
Where is the answer? Here's an
please.
answer. Okay.
Want to hear your opinion on it, please.
Sorry. I'm a small town ISP guy. So we cooperate with a lot of city carriers, small ones in Stuttgart and Tübingen and Reutlingen. So the point is, if you look at the cost structure of building the local infrastructure, there's a very good point in doing it as a public infrastructure, because all these city carriers, basically Stadtwerke, dig up the streets of your city every 30 years. So there's a business case to build this common infrastructure in one run and not dig it up every 3 years for water, for power, for gas and things like that. So the point is that the economic side of the discussion went into regulating this market in a way that leads to a brain-dead implementation, where we already dig up the streets every few years for a different part of the infrastructure. And we say we do it to separate the different parts of the infrastructure to keep this in a regulatory structure that is given by the Bundesnetzagentur. But it's not a useful structure. But the point is, if you try to publicly and politically challenge this structure of the market, it's very difficult, because all people say this can't be done. Like
so
you.
I really invite you the next time to have a talk about this. Stadtwerke, the now is small for the whole of Germany, and I'm aware of these approaches there. Even in Berlin, there were approaches like in Amsterdam that some of the infrastructure is public, but it got stuck.
Okay,
So-
that's the topic then for 36C3 or the camp.
Yes,
I
sure.
thank
It
you
is.
all for being here this early. Please thank to Swayo for having this insight.